Good afternoon, Tokyo. Great to be here, and thanks to all of you for coming here for my talk. So, a little bit of myself. I'm Huabing Zhao. I work for a company called Tetri, and I help maintain the Envoy Gateway project. I also contribute to Envoy project, mostly on the OS2 filter and some authentication components. I'm SNF's ambassador. So before we get started, I need to do a little bit of survey. So how many people have played with Envoy Gateway before this session or heard about that? Can you raise my hand? Do your hand? Okay, a couple of them. How many people know Kubernetes Gateway API before this? Okay. Thank you. So today I'm going to talk about Envoy Gateway policies, unlocking the full power of Envoy for API gateways. So before I get started, I want to start with a short story, right? So as you can probably guess, I do skateboarding. I learned the basic. I learned how to cruise around by myself. I even use it for commute, like between bus stations. So it was fun until I got a little bit ambitious. I figured, why not take it to the next level, right? How hard could a few tricks be? So just me, my board, and a dangerous amount of confidence, powered entirely by some YouTube tutorial. So this is me trying to scale down from a curb. And you can probably guess, it didn't go so well, right? The curve one. So the reason I'm showing this is just because, honestly, if you are trying to configure Envoy Proxy without right tool, feels exactly like this. Just like skateboard, the Envoy Proxy is a very cool tool. You can do a lot of cool things using it to your application. You can manage the traffic, secure service, get availability. But it's not easy. It's going to be difficult. It's going to be frustrating. And you probably feel pain at some point. So this is a really simple setup, right? The traffic comes in, hits the proxy, and get routed to the backend service. Pretty straightforward in concept. But this is how it takes to configure that in Envoy directly. I mean, that's crazy, you know? Guys, it's 2,000 lines of YAML configuration. You need to dig into all this detail like listener, filter chain, routes, cluster, matrix, login, trace, and a lot of stuff. So that's exactly the challenging. A lot of folks run into when they try to configure Envoy, either directly or maybe we try to use some homemade controller. It's not exactly easy. So Envoy gives you a lot of flexibility, a lot of power, fine-grained control over how you can control traffic, but you pay it with complexity. That's a problem. So if you are trying to configure Envoy as an API gateway without right tool, it's just like learning to skateboard without a coach, risky and painful, like I did. So that's exactly where Envoy Gateway steps in. You can think of Envoy Gateway like a coach for Envoy Proxy. It's a control plane for Envoy Proxy. You can run it for API Gateway. It's an open source project under the Envoy project umbrella. You can deploy it as an ingress gateway for your cluster. You can also run it as a standalone API gateway for your bare metal virtual machine-based application. So you don't have to handle the complex configuration directly yourself. Envoy Gateway uses the Kubernetes Gateway API to automatically manage and configure Envoy Proxy for you. Of course, it also comes with its own API, which is an extension of the Gateway API, and that unlocks more advanced features and helps you get the most out of Envoy Proxy, the capability. So you get the full power of Envoy, but with Kubernetes native simplified API and all the built-in support for routing, security, telemetry, and advanced traffic policies. So I will quickly go through some fundamental concept of Gateway API in case somebody didn't hear about it yet, because I saw not all the people raising their hand. So first one is Gateway class. So it's just define a class of gateway that shares some common configuration and behavior. For example, we have a gateway class called EG here, which is managed by the Envoy Gateway controller. And all the gateways of this class share the same configuration, like sending the tracing to the open telemetry collector. And next one is the gateway. It just defines how traffic should enter the cluster. In this example, we have a reference to the gateway class we defined earlier. And in this, we also define an ATPS listener inside it to listening on port 443 to handle the incoming ATPS request. And the last important part is routes. ATP routes just define how you can match, process, and forwarding the request to the backend service. In this example, we match all the requests to the for.example.com/store and send a request to the backend service, store service on port 3000. So this is how these pieces come together with Envoy Gateway. We got a gateway class, gateway API route, each does its own parts. And Envoy Gateway watches the resources and configure the Envoy Proxy for you. So when the request comes in, it gets routes to the right backend without even touching the low-level configuration again. So we saw that the Gateway API gave us a solid foundation. It defines some like common resources like gateway class, gateway, and API route, which works with any implementation. But here's the thing. The Gateway API is intentionally generic. It's defined as a standard that works with any implementation. So not just Envoy. That's why you can take full advantage of what Envoy has to offer by just using Gateway API, right? But luckily, we have this powerful extension mechanism called parts attachment inside the Gateway API. Just like the diagram shows, you can attach some additional configuration to the core Gateway API resources like gateways and API routes, but without needing to modify them directly. For example, we have ClientTrafficPolicy, BackendTrafficPolicy, SecurityPolicy, EnvoyExtensionPolicy, EnvoyPatchPolicy. These policies are defined by Envoy Gateway, and they are like extensions of the Gateway API. So these policies unlock Envoy's basic feature like fine-grained traffic control, advanced security like OIDC, GWT authentication, and a custom plugin like Lua, WASM, extra process, and even low-level exit patching. So you get the best of both worlds, a clean, portable API, and all the power of Envoy under the hood. Let's take a closer look at this policy. The first one is the ClientTrafficPolicy. So this policy allows you to configure a bunch of low-level collection settings for the collection between the client and the Envoy. For example, you can configure TCP timeout, like enable MTLS, and configure protocol-specific behavior for HTTP 1, 2, 3. I won't go through all the settings, a lot of stuff you can dig into later if you are interested in. So this is how you can apply it. You can attach a client traffic policy on either the gateway level or on the listener level, which means on the gateway level, all the listeners on that gateway will get the policy. On the listener level, you get only the tagged listener get the policy. For example, we have on the right side, we have a gateway called EG, which define two listeners, one ATP, one ATPS. And in the middle, this policy just applies some common configuration for both listeners, like TCP timeout, like buffer limit, something like that. And on the right side, we enable the, on the right side of this policy, tagged on this ATPS listener only using the SIG name called ATPS, and enable MTS for this ATPS listener. And the next one is the backend traffic policy. It's just on the flip side of the client traffic policy, which allow you to configure the collection between Envoy and backend. You can configure things like rate limiting, retry, load balancing, security breaker, and a bunch of low-level collection level settings, just similar to what we do in the client traffic policy. Similarly, you can also apply at the gateway level or raw level, so give you a lot of flexibility. In this example, on the right side, we have a backend traffic policy. We configure the global rate limiting, load balancing, and a secret breaker for this route only. Okay, security policy is all about access control. You can define who can access your system, how they prove they are, and what they can do. Of course, you can control which origin can access your API. Authentication, we got ATP basic, API chaos, OIDC, GWT authentication, and also fine-grained authorization. You can do like based on client request IP, GWT claim, ATP headers, and you can allow or delay access to a specific route on route level. And the most powerful thing is that if you have your own authorization system, you can also plug it in with Envoy Gateway by using the extra authorization plugin. Okay, in this example, we have a security policy on the right side, which has define OIDC authentication using Google as the OIDC provider. Also, we define an authorization rule to allow the client request from this sublet only. Okay, the next one is EnvoyExtensionPolicy. This just allows you to extend Envoy Gateway's capability beyond its built-in feature. Like if you have some custom logic, you can use this policy. Right now, we support Lua, WASM, and external process. And we're planning to support like a dynamic module and other extension mechanism in the future. Lua script, just some script you run inside Envoy Proxy. You can either write your Lua script inline in the policy, or you can also reference to a config map, like which contains maybe a more complex script. So in these two examples, they both add some header to the response. WASM. So beyond the built-in ATP remote source, Envoy Gateway also support like WASM OCA image, which give you a bunch of like advantages. First, you can use the tag of the OCA image to manage the version of WASM module. You can also put your WASM module to a private OCA registry for secure storage. Of course, you can use any existing mechanism of the OCA registry to distribute the WASM module among like a different location, different team, something like that. Yeah. Oh, here are two examples. Left one, we use like OCA registry as the WASM multiple source. Right one, we use the HTTP URL as the WASM multiple source. I just go through this real quickly because I have a demo at the end of this talk. But if you're interested, you can take a look at the details later. Okay, the last extension, external process, which gives you a little bit more flexibility, because you can use like any language you like, Java, Go, Python, whatever you like to write this. This external process is runs outside of the Envoy proxy. also give you a little bit more like isolation. So if anything goes wrong with your extension, it won't take down the whole proxy, you know. To minimize the network latency, you can use, you can deploy the actual process as a sidecar next to the proxy in the same pod, and use the Unix domain socket for the communication. So this is how you can do that. It's just very simple YAML configuration, yeah. And last but not least, Envoy patch policy. So this one is like super powerful. You can add any arbitrary patches to the generated XDS. So basically, Envoy Gateway is a translator. Translate the whatever resources into Envoy configuration. This one allows you to modify the outcome of the generated XDS. So you can use it to verify some prototype before formally landing this feature to Envoy Gateway, or maybe implement some temporary workaround if that feature is not available yet. But be careful, always test it out before you upgrade Envoy Gateway, because like XDS structure is not an exact API, so we can't guarantee it will still work after upgrading your Envoy Gateway. So make sure, test it out before you upgrade. So this is how you do like Envoy patch policy. You need to enable it in the Envoy Gateway configuration. And also, the right side we have example. We replace the default 404 response with 406 and add some like customized message body. So that's you can do that. So remember in early slide how complex it can be, right? To configure that simple setup in Envoy directly. So after we use Envoy Gateway, that's how simple it can be. So with Envoy Gateway, you just like use a couple of Kubernetes native resources. You can easily get Envoy Proxy up and running as an API gateway. So it's just like a 37.9 YAML configuration. So it's very simple. But that's just the beginning. When things really get powerful is that when you start adding policies, like security policy. So let's take a look how this works in a real example. So here we have a Candy cluster I deployed earlier. Actually, it's a recording because the conference Wi-Fi not so good, so I recorded it before. Let's see it. So in this Envoy Gateway system is where Envoy Gateway is deployed. We got Envoy Gateway control plane, and Envoy Gateway already created the Envoy proxy for us. And in the default namespace, we created a gateway resource, which we have like two listeners, one ATP, one ATPS, listening on port 80 and 443 port. So it's quite simple. And then we define a route. Okay, we define HP route. Which match the request to www.example.com/myapp and route the request to the backend service on port 3000. Yeah, that's pretty simple. Okay, this is the most important part, the policy. This is the security policy. So first of all, we have OIDC authentication defined here. It's just maybe less than 10 now YAML configuration to enable OIDC. That's it. So you got a client ID, client secret, which you can get it from your OIDC provider configuration page. And also we specify quick claim because later we'll use the GW claim from that ID token for authorization. So that's why we do that. That's it. Here we have another part, GWT authentication, which extract the GW claims from this token, cookie, from token in this cookie. So which then we can use for the authorization rule here. So if you are familiar with GW token, you probably can guess the meaning of this rule is that if your email claim matches this email, then you get access to the route. Otherwise, you are denied. Let's try it. Okay, we try to access our application. So we hit our application. Will be automatically redirected by Envoy Gateway to our OIDC provider login page. In this case, is AWS Kakalido login page. We input our credentials. Then, okay, we log in. Okay, we get access. But what if we change the authorization rule to let the ID token doesn't match my ID token? What happened? Let's see. Okay, we change the email claim value to something doesn't exist. Then we try it again. Because it doesn't match, so we are denied. And we change it back. We can let's change it back. Okay, we get access again. So that's the demo. Okay, so here's the key takeaway from Envoy Gateway. Simplify Envoy, built on the Gateway API, extended for the full Envoy capability. It's also the foundation of the Envoy AI Gateway. You can download the demo or script by scanning this QR code. You can try it out by yourself, maybe in 5 minutes if you are interested in that. Okay, thank you. That's all.
Hi. I know there is a bunch of implementations of Envoy Proxy, Gateway API implementation of Envoy Proxy, right? Like emissary ingress and K Gateway. I think they are both built on Envoy Proxy. Do you know like what's the differentiator of Envoy Gateway? How does it? Is it better than both of them, or yeah?
Okay, that's a very good question. Actually, as a maintainer of Envoy Gateway project, I don't think it's fair to answer which one is the best for you. I think that's each project has its own like advantage or disadvantage for you. Maybe they have their own focus. For example, in Envoy Gateway, we will try to build a fully open source Envoy Gateway project. We try to put every feature on Envoy Proxy in the API Gateway level. That's what we want to do. So basically, for your question, I would suggest you just compare. You maybe make a list. What do you want? What this gateway, this project offer? What this project offer? And compare each of them and make your own decision. That's my suggestion for you. Yeah.